This is question number 77 from section 1.2. It is asking us to find the x and y-intercepts of the function given, but to make it a little more complicated, instead of numerical values, we have a, b, c, and d. Our variables are still x and y. We are going to proceed the same way we would if a, b, c, and d were actual numbers. The first step is to consider what is an x-intercept. An x-intercept is where the function crosses the x-axis. This means that we know our y value will equal 0. So the first step would be to substitute 0 in for y in the function given. When we do this, we notice that c times 0 will give us 0. So we end up with ax equals b times negative d. Now our next step is to solve for x, so we need to divide both sides by a. When we do this, we have x equals negative bd all over a. This means our x-intercept will occur at negative bd over a, comma, 0. To find the y-intercept, we need to consider what is a y-intercept. It is where the function will be crossing the y-axis. So this means we know that x will have a value of 0. Hence, we will need to substitute 0 into the equation for x. When we do this, we end up with ax equals b times cy minus d. So if we put the 0 in, we have a times 0. Well, a times 0 equals 0. If we distribute the b, we get bcy minus bd. And then we'll just go ahead and add that bd to both sides, which will give us bd equals bcy. To proceed from here, we want to try to isolate the variable y. So we're going to divide both sides by bc. When we do this, b divided by b is 1, and bc divided by bc is 1, so we'll have d equals y. This means that our y-intercept is occurring at the ordered pair 0, d. Again, I know it's a little bit more complicated because there are variables instead of numbers, but we do use the same exact process.